Alright, so in this problem, I have 2 to the power of m minus 2 to the power of n is equal to 2016. So at first glance of this problem, I know that 2 to the power of m is greater than 2 to the power of n. Because if 2 to the power of m was less than 2 to the power of n, then this would not be a positive number, this would be a negative number. So if 2 to the power of m is greater than 2 to the power of n, then this also means that m is greater than n, because they're both the same base. So now that I know that m is greater than n, this must mean that m is equal to n plus some number k. So k is just a constant, some number. So now I'm going to replace m with n plus k. So now I have 2 to the power of n plus k minus 2 to the power of n is equal to 2016. Now, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 2 to the power of n plus k, that's going to equal 2 to the power of n times 2 to the power of k. Now this minus 2 to the power of n is equal to 2016. Now I'm going to factor out 2 to the power of n. So now I have 2 to the power of n times 2 to the power of k minus 1 is equal to 2016. So 2016, this is equal to 32 times 63. So as you can see here, 2 to the power of n, this is going to be an even number, right? Even, because 2 to the power of any number is even. Now 2 to the power of k, that's even, but an even number minus 1 is going to be odd. So 2 to the power of n is even, and 2 to the power of k minus 1 is odd. So now 32 here, this is even, and 63, this is odd. And notice how both of these are in the form a number times another number is equal to another number times another number. These two numbers are even, these two numbers are odd, meaning 2 to the power of n is equal to 32, and 2 to the power of k minus 1 is equal to 63. So these are my two equations. First off, 2 to the power of n equals 32. We know that n is equal to 5 because 2 to the power of 5 is equal to 32. And 2 to the power of k minus 1 equals 63. I'm going to first start by adding 1 on both sides. So now I have 2 to the power of k is equal to 64. So 2 to the power of what number equals 64? 6, meaning k equals 6. So I have my value for n and k, so all we have left to do is find the value of m. And remember, m is equal to n plus k. So n is 5, k is 6, meaning m is 11. Alright, so in this problem, I have 8 to the power of x is equal to 80. So to solve this, I'm going to first start by taking the log on both sides. So now I have log of 8 to the power of x is equal to log 80. Now if I have something in the form log a to the power of b, I can move this exponent b to the front. So this is going to equal b times log a. So in this case, I have log a to the power of x, so I can move x here to the front. So now I have x times log 80, x times log 8 is equal to log 80. So now we want to isolate x here. So I'm going to go ahead and divide both sides by log 8. So I can move log 8 to the right-hand side. So now on my left-hand side, these two are going to cancel out. And now I have x is equal to log 80 over log 8. So now log 80 here, well, 80 is the same thing as 10 times 8. So I'm going to rewrite 80 as, log of 80 as log of 10 times 8. And if I have something in the form log of a times b, this is equal to log a plus log b. So in this case, log 10 times 8, that's going to equal log 10 plus log 8, and now I have this over log 8. So now to solve this, I'm going to rewrite this as log 10 over log 8 plus log 8 over log 8. Now, anything divided by itself is 1, so log 8, those two cancel out. So now I have log 10 over log 8 plus 1. And log 10 is also 1, so I have x is equal to 1 over log 8 plus 1. So log 8, that's the same thing as 2 times log 3. Or sorry, 3 times log 2, which is equal to 2.1074. Alright, so in this problem, I have 3 to the power of x is equal to 7 to the power of x plus 2. So to solve this, first off, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So in this case, 7 to the power of x plus 2, I can rewrite as 7 to the power of x times 7 to the power of 2. Now, I'm going to go ahead and divide both sides by 7 to the power of x. So then these two cancel out, and now I'm left with 3 to the power of x over 7 to the power of x is equal to 7 squared. Now, if I have something in the form a to the power of m over a to the power of n, this is equal to, a to the power of m over b to the power of m, this is equal to a over b to the power of m. So 3 to the power of x over 7 to the power of x, that's going to equal 3 over 7 to the power of x, which is equal to 7 squared. And now I'm going to take the log on both sides, so I have log 3 over 7 to the power of x is equal to log 7 squared. And if I have something in the form log a to the power of b, I can move this exponent b to the front, so this is going to equal b times log a. So log of 3 over 7 to the power of x, I can move x to the front, and log 7 squared, I can move 2 to the front. So now I have x times log 3 over 7 is equal to 2 times log 7. And now if I divide both sides by log of 3 over 7, these two cancel out, and I have x is equal to 2 log 7 over log 3 over 7. Now, if I have something in the form log a over b, this is equal to log a minus log b. So log 3 over 7, that's going to equal log 3 minus log 7. So this is my answer.